I wanted to quickly go over sample spaces and the law of large numbers because there seem to be some struggles with that. So sample spaces are a list of all possible outcomes, and by outcomes we mean the results you could get. Okay, so a coin would be the easiest. The results you can get from a coin are only heads and tails. If you have a four-sided die, which does exist if you haven't seen one, you've only got the options of 1, 2, 3, and 4. Those are the easy ones. If you have two-sided dice that you're rolling at the exact same time, your options are both of them being 1s, the first one being a 1, second one being a 2, first one being a 1, second one being a 3, and on and on. Okay? Really importantly, when it comes to these, that the 1, 2, and the 2, 1, those are different things. Okay? The next one is suits in a deck of cards. You should be a little bit more familiar with cards if you haven't done a ton with them. You've got hearts, diamonds, spade, and clubs. The really important one with this one, though, is that for each one of these, there are 13 cards in each suit. So there's 13 different times you can draw hearts out of a deck of cards. So for each one, even though you can draw it more than once, you should only list that outcome once. Okay? So if you have a bag full of marbles and there's 4 striped marbles in there, you should only list striped in your sample space once. Okay? Never double up. The last one is kind of similar to one that's on your homework. Rolling 2 four-sided dice and adding their results. Okay, so for this one, I've already made the beginning of my list up here. That's the beginning of my list of the results I would get. So all I have to do is add them together. So first one would be 1 plus 1, which is obviously 2. And then I would get 3, 4, then 5 for the first 4. The next one is 2 plus 1. I've already got a 3 right there, so I'm not going to double up there. Okay? I'm not going to write it down again. The full rest of the sample space just goes up to 8. 7, 8, and I'm done. Okay? So if you have more than 2 things and you're not combining them at all, you can just list them together, like over here. The next part is the law of large numbers. The more trials you do in an experiment, if you keep doing the experiment over and over and over, your experimental probability gets closer and closer and closer to the theoretical probability. Okay, so the probability that you are getting for drawing a striped marble is getting closer and closer to what you thought it would be just by counting how many striped marbles there are divided by how many total marbles there are. Okay, so easy example, theoretical probability of rolling a 2 on a die is 1 out of 6. For the experimental probability, if we've done this 30 total times, we have to take the 2, which is right there, divided by total. It might not be super obvious in fraction form, so in decimal form, that 1 divided by 6 is 0.17. 3 divided by 30 is 0.1. They're different. They're not that far off, but they are different. Okay, so we're currently at 30 total trials for our experiment. If we kept doing more and more and more, not just 60, not just 90, we might have to do like 1,000 trials. But the more trials that we do, the closer and closer the experimental probability will get to the theoretical, which for us would be that 0.17. Okay? This has to do with one of the myths of when it comes to probability. The experimental probability, the thing with the trials, it has no effect on the theoretical probability. Basically, the past does not affect the present. You could roll 100 twos in a row, and that doesn't change anything. Doesn't matter what happened in the past, the probability of rolling a 2 will always stay 1/6. Okay? This is something really important called the gambler's fallacy.